Hi, it's Gadget UK here again. The time has come to build my birthday present from last year, 2023, I think. So this was amazingly donated by the people you just saw on that card. It's incredible. Yeah, I've been waiting, really eager to build this for so long. Now, the interesting thing is I've got two of these because I don't know how this came about. And actually I think I've got another one of these, as you'll see. One that came from Cavados, and it's just the one that came from him. Well, this one probably came from him, but it was a special one, the other one. Well, they're all special. The point being, though, I've got the blank one here, and I've lost track of how I obtained this blank one. Probably from Barry and Cavados. But then we got this one for my birthday, so let's just cut the tape here. And as I say, there's another one, a special one, a different one. Something that's slightly different from the standard BFG. But we'll cover that in another video. That came from Cavados, which was, again, just absolutely incredible. I am so blessed with the support that I get on my channel. All of these people are just amazing, absolutely amazing. So I've got all the parts I think we need there to get onto this PCB. I never like soldering those Xilinx chips, but we got the microscope from Cavados. We'll give that a go. So this is BFG sockets, look. Wow, a few different types of connector there. Not just the 060 socket, but we'll have a look in a sec. Yeah, so we've got two of those things there that right now I forget the name of. Got the 060 socket, PLCC socket for BIOS, I think. We've got the fan here that came from Stephen Leary, actually super duper. But it was the one that's created by Goose, and I think I'm going to use that on here because it's going to fit nicely, isn't it? And it will fit within 4,000 or 3,000. With a CD32, that would have been very difficult to fit that on there. And then we've got a load of capacitors here. Ah, those are for someone else. Yeah, these are for another project. And we've got the Kel connector here. Very nice. So that's going to go on there, and then it can fit into a 3,000 or 4,000. It'd be interesting to see the difference between these two PCBs. I think this one is pretty bare, isn't it? Yeah, it's not even got any of the caps and things on it, that one. Which is interesting. I'm not really sure, like I say, where that one came from. It may have come alongside this one. I don't know. But this one is, I think, JLC. Yeah, I can feel already that the capacitors and things, well, many of them are already fitted on the underside of it. Oh, that's gorgeous. Let me get the wrist strap on before we handle this PCB. It'd be interesting to see how assembled it is. I'm not sure what comes on these from. Oh wow, it comes with a RAM, look. I think that's RAM. It looks like it's RAM Winbond. It's got to be RAM that. Yeah, Winbond W9825G6KH-6, 60 nanoseconds. So it's got everything on here, look, all the little caps, inductors, diodes, resistors, resistor arrays, all the chicken feed on the underside. JLC PCB do a really good job on assembly. It looks wonderful, that, doesn't it? Let's just compare it to this. Yeah, so they look like the same revision, don't they? This one's obviously, you know, solder coated. This one's got, you know, the gold things there. So, I don't know, that's interesting, the difference between the two. I think they've both been manufactured by JLC PCB, though. So, yeah, that's cool. I'm kicking myself that I can't remember where I got that second PCB. It may be that Barry offered it out and said, does anyone want a blank PCB? I'm like, I'll have that. And then I purchased it. I don't know if you know how I got that. Please remind me, because, well, I can't remember. I've started now to write things on things so that I don't forget where and when I purchased or picked up something or was donated something. Anyway, in any case, this is just incredible. It really is incredible. I've been so excited to build this for well over a year. I just had way too many things that I needed to get out of the way, though. So, yeah, we've got the connectors and things to go on this. So, one goes there, one goes there. We've got the Kel connector to go down there. Socket. Where's the other socket? Other socket. And then these parts. So there's not a massive amount solder on there, but you're well fairly complex, and you know, harder to get these on maybe than that. That's going to be pretty easy. So I've got a little voltage regulation module there, you know, it's going to use, you know, a buck converter. That's really nice, that. That's going to go on down here, isn't it? Got 3 pins and then 2 pins, as you can see there. So, yeah, that's going to be nice and easy to get on. It's going to go like that. Could just leave that there for now, but anyway, we'll take that off because I'm going to put the 2 chips on first, the surface mount ones. We've got a third surface at 4. We've got 2 more surface mounts ones there. What are those? Those are going to be these, aren't they? LV something. 16543. I think, isn't that a combination of a latch and buffer or something like that? Level translation, I think, effectively. And we've got a small little SOIC thing there. Can't really see what that is. It's going to be a clock, you know, a PLL or something, isn't it, I think? 4292077. I think that's going to be some sort of clock gen thing. I could be wrong. There's a tiny, tiny, tiny little IC there. I mean, it's really small, that little thing. That is marked LTD SQ E3. I wonder what that is. And where it goes. I mean, there's room for 3 things up here. There might just be. Yeah, it says A1, A3. Oh, there's a tiny little IC next to it there, though. That's where that's going to go, that tiny, tiny, tiny little one. And then the slightly bigger one is going to go down here. And we've got some jumpers and pin headers and things as well. So we've certainly got quite a few components to stick on this. I think we'll start with the smaller CPLD, actually. We'll get that on. Yeah, so we're using CavCam on a board that I think Cavanos helped provide using Cav tweezers. Welcome to the Cav channel. Hang on a minute. Where's the chip gone now? Right, so it's over here. So I've got pin 1 there. Yeah, there we go. So that's what we want. We want this down here, I think. Hang on. Yeah, there you go. There's the pin 1. So, God, my nails need cutting again. I've not had that for a while on my channel. I'm usually better at keeping them trimmed. Yeah, so I think what we'll do is we'll just sort of squish this into position here, solder a point and then adjust it. But you can see I pretty much just nailed that. That's spot on. That is spot on. It won't stay spot on, I'm sure it'll move in a minute. You can blue tack a chip like this down. You really should have a very fine point on your iron when you're trying to anchor small points like that. Just putting some water into the sponge here, hang on. And I'll show you what I mean. You know, you should always wet your sponge just a little bit so that you can wipe solder off your tip. That sponge is decrepit. I've got some new sponges coming, actually, some cheap ones from AliExpress. They were like a 50p each or something. An official Heiko one is about £7 or £8. Yeah, it's going to move this because look at the size of the tip. Trying to get that, and what you can do, this is a technique, get your solder on the point, because then when you melt it, sometimes as it heats up, the solder will just flow to the point, and it's not doing. Oh my god, you can see what's happening here. If I just bring the tip in the iron, can you see it's like it's going into the wrong point of the tip. This is why it's important to get a bigger tip. But I can use a shallow angle like that, there we go, and achieve it. Yeah, so sometimes it's about the angle you approach. Now look at that now, after rotating that round, that's not straight. But you look from that angle, well no, maybe it has moved. Yeah, because it was better aligned than that before, wasn't it? So I'm just going to just gently push it as I heat those 2 pins. There we go, like that. So now they're straight, they're off a little bit, and the top side's off a little bit, just ever so slightly. So I think what we'll do is probably come around this side here, and we can see here it's not 100%, you know, as straight as it should be. But what I will do is just get some solder there, it's a few pins like that, that'll do. Just rotate it around this way, and then we're going to push this way, down this way, just marginally, just a little bit as we heat these 3 pins. Like that, I think. Then let go. Then re-inspect it and go, yeah, they're nice and straight. And then check this side, nice and straight. And check, hang on, oh god, where's the camera gone? that side nice and straight. And then what I'll do is just reflow these points here, just a little bit like that, just to let any tension out. But they probably, you know, they will have moved a little bit, so they've got slightly bent by the process there. And then we'll get some of this cheap fake Amtech around here, because I'm out of chip quick at the moment. Oh hang on, it's this one where you've got to squeeze incredibly hard, and then you get a time dilation release where a few seconds later it starts coming out. Here we go. So we're getting a gradual release here. Anyway, I'll report back in 10 minutes when I've managed to get some flux on it. And what is this board? Well, it's a CPU card for a 3000 or 4000. It gives you an 060. I think it provides 128 mega RAM. Might be more than that, I don't know, but I think it's 128 mega RAM. And I think it has IDE, does it? No, it doesn't actually, looking at it. I'm not sure what that ROM's for. It's probably just some sort of bootstrap ROM to get the 060 working regardless of your kickstart, something like that, I suspect. Anyway, yeah, this time dilation flux is a pain, look, it just keeps coming out. It keeps coming out. Bear in mind, this tip is probably not the best tip. I may swap to the Antex in a minute. Now, I'm using the new tip I got from Brian, but it's still nowhere near the same as that Antex tip. You'll see what I mean. You could introduce the solder as you hit the pads there, but yeah, you'll see what I mean. I don't know, maybe it'll do a good job, I don't know. Let's just see, just have a slow drag, and you want to try and touch the bottom where the connection on the PCB is, rather than the pin. Yeah, it's not working very well, that. In the meantime, I might just go around to another side here, and let's have a go at trying to distribute that, maybe. Again, it's still not warm enough yet. Yeah, I'm successfully showing that this iron is not much better. I've still got a bit of COVID, by the way, if I sound a bit coarse. Yeah, so we've managed to get bridges all up there. You can't really see that. But the iron isn't quite warm enough, if you ask me. You can see on these pins here, it is working. Yeah, we are getting solder, and it's not going up the pins. It's just where we've got it places like that, where it's like right up there. We'll need some more flux to deal with that. And granted, these solder points don't look so clever. Let's just move this up that way. Yeah, it's not moved. So let's get some more flux. The flux is what the issue is right now for me here. Yeah, you can see I managed to move that around a bit there. Not where I want it though. This is the problem. You could try and turn into the pin like this, sometimes leading, you know, the tip when it's a certain shape can sometimes help, and sometimes bobbing in and bobbing out can help. Wow, I've got loads of solder there. Right, let's get some braid. I mean, look, it doesn't even absorb properly onto that. All flux just behaves differently, really. It's almost alright now. We've just got a few pins that need a bit more solder there, and then we have got this blob here. Right, that might be it. And of course, when I'm fitting a chip like this, I would much prefer that it went on, well, as I would normally do it, just like in 1 or 2 passes like that. So I spent more time, a lot more time than normal, just doing that one side because of that flux and because of the other tip. Let's try the next side. Let's get some more focus. Let's So now we've got a better tip and the iron's warmed up a bit. We've got awful flux. Let's just see how we get on here. Some people sort of put some solder like that and then, you know, sort of go down the solder or lead, you know, lead along like that. Getting big blobs, look, ugh. I'm tempted to just go up it like that actually, and then on the pads. Just deliberately bridge some of this stuff here until we get some solder distributed. And incidentally, this braid is crap as well. Everything I'm using here is a bit crap at the moment. Not all braid is the same. Not all flux is the same. Wow. So I've still got a bridge there. Let's just see if we can distribute that somewhat. See if we can get rid of that the ideal way, which is just to drag around a bit, but nope. Let's just see if more flux has come out. Yeah, it has. On our time dilation flux dispenser. You know, it's giving me the flux now from the squeeze that I did 20 minutes ago. You see that? That went with a bit of flux. Compared to the Chip Quick, this stuff's really liquidy as well. You can see, you know, it's like looks really glossy and wet. Let's just have a quick drag. Yeah, it's quite difficult with these caps. I think you'll agree that's not too bad, I think. It's quite hard to see because of the flux. Anyway, that's 2 sides done. I'll report back when I've done the other 2 sides. Right, I managed that. I found that incredibly difficult with that flux. I used a magnifier from my parents just to finish off the remaining 2 sides, and it's a bit easier because you can get, you know, you get at an angle down that way instead of straight down, and I just found it a bit easier to see what I was doing. But the microscope is essential for inspection. You can, you know, you can fit with the microscope, that's for sure, and you can certainly see more detail here. You know, so like when it comes to maybe your final reflow, this is where it is useful. This side here I found the hardest bit. Yeah, I don't know if you can see where the Xilinx print is there. It's like, I think there's a load of grounds or VCC connections here because as I heat those, it feels like it's absorbing a ton of heat on the first several pins there. That's it, so I'm going to now clean up with cotton buds and IPA. This type of wet flux like this, it's supposed to be no clean, as a lot of this stuff is. I'm just going to absorb as much of this as I can before I start to add the IPA, because you can see there's just considerable amount. I mean, this is one of the differences between the Chip Quick stuff. Not only is the Chip Quick stuff easier, if you ask me, and works better, this cheap fake flux here, you end up using loads of it, and it obviously makes much more of a mess. You know, I have to absorb all of this before I can really start to even attempt to clean up. So much of it around here. No clean, yeah, right. Can you imagine not cleaning that? Right, let's get a bit of IPA now. But you see, without a toothbrush you wouldn't get in and around all the little crevices there and in between the pins. Anyway, that's one chip on. Doesn't look too bad from the top, I don't think. Yeah, so this larger chip is a 288, isn't it? Let's just see if we can get that. It's tell you to use a vacuum or suction device to remove these from these foam things. That's got the chip stuck to that, and pin 1 is there, isn't it? So I need to just carefully, wrist strap is on, rotate this around that way, and do inspect the pens and these chips before you know, commit to completely soldering them on. Yeah, so pin 1 is definitely there, isn't it? Yeah, that's it. Right, that's those two chips soldered in place. So the solder points on them look okay, and it's fairly clean, the PCB, so far. So I'm going to get that little IC on down there, and the tiny little IC up there, then get those two on, and then just get the through-hole bits on, and I think we're done, other than programming it up. So let's get that tiny, evil, really small IC on there. So using the tweezers to take it from the sponge. Right, I can see where pin 1 is. So pin 1's here, and pin 1's there on the PCB. It wants to go this way around. You can argue that the diameter of the solder I'm using is way too... Hang on, I don't want to avoid... I want to avoid moving all the blooming solder from these things. Yeah, you can get finer braid as well, by the way. The braid doesn't need to be as thick as this. I'm sure we got a bridge there, the first two. Maybe not now. Right, so what I'll do now is I will use this up close to look down at 45 degrees as I reflow that, because I can see the solder points really clearly and the backs of them. There we go, yeah, that's flowing really nicely, there's enough solder. Yeah, you'd think now that JLC PCB would fit that. You can see there's no flux or anything. Just do that, let's just get some solder there. And I'm onto the final two SMD ICs here. So pin 1 is there. Let's just try and get that into shot. There we go, pin 1. So I'm not going to show you everything here, I'll just anchor this and then I'll cut to it, hopefully, having them on. I might show you some of the soldering on this because it's going to be a bit of a pain, because if look at the stuff here, that chip's right next to it. It just limits access a little bit. Most of it there we go. And here, giant blob. Right, we are so near the end now, so I'm going to get these two connectors on, the keyed. So there's a little mark there to show you where the gap goes, so we'll just anchor these on and then just solder them all in one hit. So I've got our 060 socket as well. May as well anchor that in position. Yeah, always check your pins on these to make sure they're all okay. And we should have one pin missing there, which corresponds with the top left there. So yeah, it's hard to get that wrong. Right, that's most of the jumpers. I've got one here that where it's been cut and it's hanging on there. You can see that. It's like I'll just get another piece of pin strip for that, that's not a problem. Now, is this keyed? Right, a word of warning, check your pin 1 before you solder on your kel connector. That was an absolute mare to get off. I only anchored like 4 points on it or something. And would they solder? Would they heck? I suspect they were like VCC or ground. So you can see what's happened here. The base has come off because a pin on each side wouldn't come out. So the connector came off really easy and lifted like this. The handy thing with that is I could work out which pin it was, but we now need to try and fix this. And I think it should be straightforward. It's just a case of gently massaging it back so that the pin goes back into its channel. Hopefully. I don't know. It doesn't look like it's bent, I just think it's just come apart. I don't know, could be destroyed. I do have some spares of these if I have destroyed this, so anyway, I'll report back in a minute. I need to do it under magnification. Yeah, and just comparing to one of the two Kels I've got left, I did have 3 each of these. I gave one of the male and female sides to Sparks UK a while back. I remember doing that, I think. Yeah, the gap, it's, I don't know, 1 or 2 millimetres, a couple of millimetres probably, the plastic bit, and that's what I was just looking at. After struggling to get this back together. I managed to do it, and I think the gap, yeah, it's about the same, and it looks nice and straight. It's gone through okay. The key when you're pushing those pins back in when they come out like my corner ones did is looking down the profile here. I'll show you on the microscope just to make sure they're all pointing upwards properly, you know, they're all at the top of the gap. Yeah, and my lunch, by the way, it's just a vegan burger. It's not quite as unhealthy as it looks. It's got a slice of Edam on it as well. Not that it really needs any more cheese. You can see that the space is linear all the way along that. So yeah, it was a bit fiddly to get that back together. But the key is looking into the slot here, like this, and checking, you know, these corner pins, because these are the ones that came out. One of them on each side, I think. Just making sure. And that second one looks a bit low. You can see that. Yeah, the second one just needs pushing upwards slightly, I think. And you do it by the actual, you know, the solder point, if that makes sense. The solder point is the thing. So you know what, I've recovered that, that's alright. That's good enough to go back together, I think. Even that one over here. Yeah, the second one on that side, let's just get more focus. Actually, that's alright, it's just deceptive. I think that's okay. But you know, the key here, and I always mess something up on every single build, it's without fail. It says 1 here on the PCB, and then you've got this arrow here, points to pin 1. Before, I had it the other way around, and you can do that, I think. I'm sure it was the wrong way around, because I looked and I saw the one here, and I saw the arrow here was somewhere over here or something. It was like round the wrong way. So, yeah, that was lucky. But it was very difficult to desolder. It really was. Reading some of the information from the wiki here, it's just helping make sense of something Kavanagh's just said. I think he said with the writing to the left here, you know, reading it that way, 5 of the jumpers need set to the left, and I can see 1, 2, 3, 4, 5. I think there's 6 actually, there's another one somewhere else. Oh, maybe there isn't. 1, 2, 3, 4, 5. Yeah, I think it's just 5. And they all need to be set to the left, so I thought, let's have a read through this documentation and see what it says. CPU can either be an 040 or an 060. It says popular L2 or L4 for an 060. I've checked, and I think it's one of them's here and one of them's over there. And then it says if you're using an 040, you set L3 and L5, and that's the ones where this component's missing. I want to check that just because I was a bit concerned that we're missing 2 inductors there. So those are correct. There's a resistor missing somewhere as well. I want to check that. There it is. I think R8 or R5. I can't read it from here. It says the clock multiplier is controlled via small 2mm jumpers on JP2. S0 on, S1 off is 100 MHz. S0 open, S1 open is 75. S1 closed, S0 closed is 50 MHz. So yeah, I think we'll just go with 50 MHz. So those, where are those? It's that 4-pin one, wherever that is. It's up here, isn't it? Yeah, S0 and S1. So I think those both need to be over to the right. So that would set them both to a 1, which should give us 50. I just want to go with 50 to start with. Anyway, we can now start to solder these ones, I think. Here, I'll just confirm that which jumpers are which, and the other 2 I'll tell you about in a second, because obviously 2 of these here for voltage or something, I think. I'm not sure actually, it doesn't actually tell me what those are for. Yeah, I'll talk about those more later. I'm just going to solder them all to the left position for now. Alright, so that's the 68060 socket and the PLCC ROM socket soldered on. I'm just trying to work out what IC I've got on here. I think this is the 570B. If I rotate the light, you can see 570B there. Right, all the soldering complete, so I'm going to put it in the ultrasonic cleaner. Yes, so just preparing to program this, just trying to work this out, and we'll power it first on the Agilent, I think, before taking it through and connecting it to USB. and just see if anything gets hot. I've inspected around everything, everything looks alright, and you saw it go through the ultrasonic, it's pristine, there's not even a fibre on it. I'm very, very pleased with how clean that's come out. But I was looking at this 5-volt fan header here, these 3 pins. You've got ground at the top, 5 volts in the middle, not connected. And if I go to the middle pin, because I was thinking I could use this to power it, just to program, that is, the fan header. And on the regulator here, the V in pin, dead short, the ground pin goes over here to ground, yeah? And then I think V out is on the end, so if we check to ground, nothing, 5 volts, nothing. So I could power here with my USB cable on the PC to provide 5 volts to this, which then means it's providing 3.3 to these. So I quite like that 5-volt fan header there. Yeah, so I guess the intention with this is you fit a 5-volt fan. 5-volt fans are quieter anyway, aren't they? But you could always just, run 12 volts from your 4000 or your 3000 from one of the Molex connectors and stick it on top. You don't necessarily need to use that, so I quite like that. And as I mentioned earlier when I was building this, I was like, have we got 2 JTAG headers here? I wonder what that's for. And something else that's been explained as well, I'll cover in a sec. This one here is a JTAG. It's for the CPU. You can actually JTAG the 68060 and have a look at diagnostic information and stuff maybe from it. There's a jumper there that goes with it. CPU JTAG N, I think it is, or something. So I might fit that 2-pin header later. And if you fit that on there, then obviously this becomes relevant. These 2 jumpers here, as marked on the board, there's 2 arrows on either side, show you, I think you go that way with both of them. This is for the 060 CPU temperature monitoring. Now, I've mentioned that in the past, that an 060 as default's got a little thermistor or whatever it is built in, a resistor that changes with temperature. But you've got to calibrate it, and I think you have to take these off and measure the resistance between them and then type that into the software or something and then put the jumpers on. And you need to do it at a point when it's cold, I think, or maybe lukewarm. I'm not honestly sure. We'll have a look at that, see if we can calibrate that. So when those are enabled, it's capable of reading the CPU temperature. But if you don't do that calibration, because they vary so much on these 060s, you might be 10 or 20 degrees out, you might have a delta of, like 10 degrees or something. So you do need to do that calibration. Oh yeah, SCL SDA. I wondered about this for a while. I think this is, you can do a voltage monitor. You attach something to this, a voltage monitoring device, and you can actually read from that. It's at a certain address, I think. I'm not honestly sure with that. But that's what SCL and SDA is. You've got like a clock and a data or something. Some sort of serial type connection, I think. There's one of those on a lot of these projects from Matthias Heinrichs. Yeah, got it right this time. Copyright 2022, free for non-commercial production. So you can buy these. There are a few of the main Amiga distributors selling these, and they're contributing a donation to Matthias, from what I understand. A bit like with the Terrible Fireboards, and the Terrible Fireboards are out now, I think, the TF4060. If I referred to this as a BFG9060, I am sorry, because it's not, is it? I think it was originally, and they changed it to 9060, because I think it will run at 90 without an issue. You could run 100 with a Rev 6. So I'll connect 5 volts and ground here, and then just measure that we've got 3.3 volts coming out of here, temperature, feel these things. And at that point we can then go away, connect the JTAG here, and hopefully program up these 2 CPLDs. So I've got the wires very carefully connected there. It's not straight, that, is it? Let's just see if we can move it a bit. God, that's heavy, as you imagine it would be. And I've switched it on. Yeah, I've set it to 500 milliamp as a limit, but you can see it's drawing 92 milliamp there, 5 volts, and it's in constant voltage. Constant voltage. So it's not drawing anything really, which is what you'd expect really when it's in a state. Don't use croc clips like this. I'm taking a bit of a risk. You want a proper pin header. I'm being very careful to make sure that there's no chance those can short. So if I now switch it on and just watch it again, hang on, 90 milliamps again, and if I go from ground here to, hang on, V out over here, you can see they're 3.27 on the meter. And if I just have a feel on tops of these, stone cold, as you'd expect, because it'd be drawing a lot more current if there was a short. So we don't seem to have any shorts or anything, and it's providing 3.3. Another check you really should do is check up here. And we can check that with the ferrites, can't we? We've got a couple of ferrites that provide the power. So like one of them is over here. If I go from ground to L4, you can see there 3.27, and then there's another flow rate over here, L2, 3.27 volts again. So those are the checks you want to do. You could go a step further and follow to the connections on here, but well, why would you want to do that? The key really is those flow rates. If those two flow rates are in place, yeah, according to the 060 settings, because there's two pads on this board, I'll show you that as well, that are unfitted, and if I measure one of those, the blank pad, you know, spare pad, 5 volts look, and then the other one where it's not fitted, 5 volts look. So if you did have those fitted, you'd be feeding 5 volts to this socket here, and you could use an 040, I think, because it does support, well, I know it supports an 040. Anyway, let's go try program it. So I'm just doing a little mod here that I did to another project for Matthias Heinrichs, and that was to just add 3.3 volt into the JTAG header there. He's got 5 volts. Now that's going to work really well with the Raspberry Pi, because Raspberry Pi is not going to check the status of the 3.3 volts. The official Xilinx cable does. So we need 3.3 volts on the JTAG header. You don't necessarily need it there, you could just feed it from a, I don't know, Japon or something somehow from the board. But there are unused pins, and I just measure around, I'll show you that in a minute, because there's still a few more that I could have picked from that aren't, you know, wired anywhere. And the way you check that is, well, you can look at the board layout, but check from, you know, resistance between 3.3, 5 and ground to the pin in question, and if you just get open line, chances are it's not soldered to anything. So there's 2 or 3 pins there that I could choose, and I picked one next to the ground. Yeah, so the bottom one is ground, then we've got 3.3 ground at the top as well. So I've got my 5 volts and ground at the top, with ground at the top, and the next pin down on the side is 5 volts, and then I've got the red and black on the ground, and the 3.3 that I introduced second from the bottom there, which goes to that cap, and then the TMS, TDI, TDO, TCK, etc. all go down this side here. As you can see in this diagram here, it's not very clear. I don't like this type of diagram where it's an isometric socket where you've got 2 lots of pins twice, if you sort of mean, and it's like that black there. You can see it goes to the left hand of these 2 pins, but I don't know, I just don't like isometric things like that. It's better just to show the 8 or 10 dots and then the wires go into each one, rather than try and make it arty like that, because you can see it's 3D in style. Anyway, so the only difference we've done is that second pin down there on the left side is 3.3, yeah, and I've powered, hang on, just wondering where the 5 volts is showing. The 5 volts as the second pin down. Let's just check that. Yeah, that's right. What it doesn't show you is this top pin here. That's actually a ground. Oh god. Yeah, that pin next to the red one is a ground. So I went ground, VCC, you know, 5 volts with my USB cable, and then my 3.3 is this the second pin down on that row. Anyway, let's go give it a try and see if we can program it up. So using the Xilinx program here, the same way we've done hundreds of times before, using Impact 10.1 I think, and I double click on boundary scan and then right click to choose initialize chain, and then it pops up with 2 chips and it asks you for the JED file for each one. You can see them assigned there, and then right click choose program. You can also do right click verify afterwards if you want. And then I used the TL866, this was before I got my T48, to select the relevant EEPROM chip type, and I got that in a PLCC adapter, stuck that into the Mini Pro there, and programmed that up with the BIOS image from Matt Say's GitLab page. Right, so you saw me program those things up. I didn't show you selection in the actual JEDs. There are 2 different JEDs, whether you want an 040 or an 060 for the, is it MCP or M? I can't remember what it was now. I'll stick it up there. There was one of them that was named with 3 letters. and you select the one that's just the 3 letters if it's an 060, or you select the one that's got 040 in the file name if you're putting an 040 on, but you need the jumper set properly. So yeah, I checked temperature and stuff, there was nothing getting warm at all, the way things stand. I wouldn't program it with a CPU in, that's just going to put additional load on things. It's better to just program it without a CPU. So we're all done. It's gone a little bit too easy for my liking. I'm kind of expecting some sort of problem. I mean, I've inspected around those chips, they look alright, but you never know, we could have a bridge somewhere that I can't see. I've been caught out recently with that once or twice, haven't I? Certainly when I did the TF360 build, I had no end of trouble with that, but one of the chips was bad on that. It was an AliExpress special, so the writing, you can read it as you stick it in like that, so you know you've got it the right way around. And I'm not going to stick the CPU in there until we've just measured the pins, you know, VCC pins on the socket, and just make sure it doesn't go nuclear. So we'll boot it with no CPU. Well, not boot, we'll power it with no CPU. And it's a shame I wasn't filming it. When I went off to take that board with a J-tag, I was carefully carrying it with all the cables, with the wrist strap on, and I got all the way across the room to the door, and I was like, why is my left arm a bit sensitive? I can't seem to move my arm. The cable was extended by about 5 meters or something. Right, we've got the 4000 on the bench here. I'm going to go with the original CPU here to start with. Just make sure this board still works before we inflict the BFG upon it. And I mean that in the politest possible way. I'm sure the BFG will be fine, but you never know. If it doesn't work and kills the Amiga, we'll never know that it killed the Amiga, will we? We'll be like, maybe the Amiga didn't work to start with. So anyway, let's get that in. The jumpers are internal, I think, so let's switch that on. It's looking for ID, isn't it, as well as floppy? I think. It's taking ages, that. There we go. Let's switch it off and let's get this card in. I need to set the jumpers here to external. Hang on. I'm confused now. Oh yeah, they go across to the right, don't they? I was thinking, where do we move them to? Yeah, you move them from the left position to the right position. As we know, this inductor down here is what goes to the VCC connections. So we've got one there. So like if we were to measure that one, and I'll put the meter probe, hang on, into the ground hole, if I can get it to stay in there. There you go, 3.2 volts. So I've got no reason to suspect there's going to be a voltage issue there. Switch it off, just have a feel again. Stone cold, absolutely stone cold. As you'd imagine, because there's nothing clocked, you know, nothing clocking data and stuff through. But the jumpers might not be right. It may need to be internal, not external, external. Yeah, here's an LC. So this one's an RC66, isn't it? Now we've got this set to 50 megahertz with its, well, I think, if I set the jumpers right, on the BFG. So just having an inspection around those pins. Yeah, they're fairly straight. I don't see any bent ones. So the missing pin is up here in the corner, and this is what I go for. I'd look for the missing corner pin, it's this one here, and correspond it with that. Now for this, actually it's better off taking it off the board, just because you can get pressure with your hands underneath, wrist strap on, like that. Let's give that a try. Now if all's well, and the jumpers are right, it should give us some coloured bands or something. Just make sure there's nothing shorting under there. No. Move those out of the way. And let's try powering that on. I'm just going to put my finger on there. You see, we didn't see any coloured bands. So, you know what? Maybe it needs to be set internal. Yeah, just switch that off. I got the bands, so it's internal. There you go. It's not producing its own clocks. It is using the motherboard. Must be like, I don't know, I'm trying to think. You know, stepping up from 50 to 100. If you set the jumpers to 75, I think, or 100, I think it'll do 100. Woohoo! It's working. Wow. I'm so excited. We need to boot from a hard disk next, I think. It seems to have gone too well, this, doesn't it? Let's switch it off. I mean, to be fair, there wasn't really a massive amount to put on. That's just lukewarm. Hardly anything, hardly any temperature at all, just like room, you know, a few degrees above room temperature here. So I'm very pleased. We know that it's booting from that because we're getting the coloured bands. We know it's booting from this because that uses that for the coloured bands. There's no other CPU on here. So you know what? I think that's it. I think let's just try and boot some stuff and see how it performs really. Be interested to see if we can go beyond the 66 that this chip is rated at. It is an RC66, and despite the fact it's an RC66, I think, yeah, it's, hang on, it starts with LC though. No, it's a 68LC060 RC66. So yeah, it's got an MMU, and this is where I get confused with the partners on these chips. You get an RC66, can't you? So what's the RC on the end? I don't know. It's weird, isn't it, the variation? I don't know what rev mask this is, I won't be able to tell. Might be, I don't know, it's got 03 down there. I don't know. Anyway, let me go and get a hard disk. Right, I've got the compact flash card from my 4000 in there. The box one, switch it on. It is very, very fast. It's faster at booting than any other 4000 I've come across yet. So yeah, you do get that delay, but obviously it's because it's like a floppy drive. If you put a floppy terminator on there or a floppy drive, it boots a lot quicker. But once it starts to boot, it boots pretty blooming quick. Well, from my compact flash card setup it does. Woohoo, we're booted up. And we've got 145 meg. So that's a combination of the 128 meg and the 16 meg on board. So it says there AGA060. Oh, so pleased. Let's have a look here, see what rev it is. Oh, it's a rev 4. Yeah, I think a lot of the LC ones are. 68 LC060, 50 MHz rev 4. So I will try stepping up in speed, see if we can. I think it'll do 75, won't it? It goes up in 25 MHz increments, I think. Everything seems to be working there. Let's try and load an 060. No, we can't load an 060 demo because we've not got a full CPU. We can load ScumVM, I think. I think that should work on here. And it's usually relatively quick on the 4000. This bit takes a while where you get this blank screen here. So we'll do Sam and Max hit the road. I like watching the intro on that. Hang on, I don't want to do that. I just want to double click down. I'll do start. Let me turn it up. Let's just see. Bear in mind, it's only 50 megahertz at the moment.
We've only gone out together 3 times, and already you're telling me you just want to be friends.
Yeah, that's really good. I want to check the IDE performance in a sec. That may have changed a little bit, I don't know. But I mean, that runs seamlessly. Considering we're just at 50 megahertz, but this is what you get with the TF4060 Proto as well. It runs really, really well at this version of ScumVM. I'm not sure it's an AGA version, this actually. Thinking about it, it must be. The interesting thing with the 4000 as well is you get very few delays on this. I can run this on the 1200 using the TF1260 and I get delays every now and again as it loads the next bit in. And if you look at the IDE speed, it's way faster than this 4000 is. So there's some sort of bottleneck on the 1200 that doesn't exist on the 4000. The only difference I've got, well, I was going to say, on my main machine is Kickstart 3.9. But this is running 3.1, so you know what, even that's been ruled out this way. Anyway, that is performing really, really well. I don't have a keyboard connected here, so I mean I can try and skip. I think you've got to press escape actually on the keyboard to skip. And running sysinfo there, you can see 37432. That's a bit faster than the other 060 cards I've looked at. And the chip speed's way faster, 7.71 times. That is incredible. So, yeah, it's showing FPU, there isn't an FPU. I'm just running the LC version of sysinfo. It's like a hack just to quickly get this working with LC chips. Let's just have a look at boards. Yeah, it reports itself there as a a Zara device for the ROM, 512K. That's interesting. And if we have a look at drives, I'm curious to see what the drive speed is. I think I get about 2.2 2 megish with the TF4060 Proto. Can't imagine that's changed much. Yeah, 2.5, so it's a little bit faster. There is a bit more speed there than I get with the TF4060 Proto. But you see, from what I understand, the memory throughput on this is quite a lot more. I mean, we're seeing that evidence there in the chip mem. Let's just have a look at AIBB. So when we do mem test here, and I'll compare to the 4060. Yes, so we're right up there at 21, aren't we? And of course there are more benchmarks, other benchmarks that give you more granularity. But I mean, already I'm damn impressed with this. It runs really, really well. It runs really fast. I need to test for stability. But yeah, I think this is really good. Yeah, I've not got any RTG or anything, so I'll just do NTSC low res. I'm not sure if... Oh yeah, I was going to say, I thought that cut over to RTG for a minute. That's not fitted. Ah, yeah. I was thinking it was taking ages to load, it wasn't. So yeah, you can see we can move around pretty quick. Yeah, I now need to connect the joystick up because, well, I can't move. Yeah, it's slightly jerky in this resolution. This would be really good on an RTG. Now we've got one of those, I can perhaps show you that in another video. Yeah, so it runs really well. But to be fair, this game runs pretty well on a 50 MHz 030. So it's not like you need an 060 to play this. Something like the TF536 plays this exceptionally well. And in case you're wondering how I was playing that, I was using a Mega Drive pad with the Mega Multi from James over at Retro HQ. There'll be a link to the video top right. So I've been testing this for a while. I noticed a problem with my 4000 that's gone into the 4000 repair. You may or may not have seen that. It's lukewarm, and I had a mouse problem, by the way, and it was nothing to do with the BFG, and that was the mouse. Again, that'll be in a separate video. So it's only lukewarm after half an hour of testing plenty of games, and it's pretty solid. Well, absolutely solid. I haven't had a single issue. So I think no jumpers on gives you 75, I think. It says unstable at the moment. We could try 100. It's a 66 MHz power, isn't it? I doubt it'll work, but let's try. S0 on and S1 off. Yeah, I don't have the wrist strap on just now. Should have. Just carefully get that on. Switch it on. It's booted. Oh, we got a yellow screen. And yeah, this is the thing. So look, boots, then yellow screen. So yeah, but it won't do 100. Look, I've got another 060. Might try that. The other one's a. I think this is a 75 MHz one I've got, but I might test that later. We'll try 75 MHz, which I think was off and off, wasn't it? So put them both down, and then we can put them both back up to 50 if it's not going to work. I know a few people have had problems running these at 100. I think Liv2's got one of these, and I think he couldn't get 100 out of his. So that's 75. Just looking to see if the IDE kicks in. At the moment, it's just got the grey background. Yeah, I think it is unstable, isn't it? I think that's not doing anything at 75. I was trying to work out which way that jumper went. So put it back to 50. Hopefully it's going to boot. Yeah, I got the coloured bands again. So with this 66 MHz part, the best I can do at the moment is 50. I thought it would be prudent just to test the 128 meg. So boot and test kit, but I also used this to test the mouse and the controller out a minute ago. Because there's this weird thing with Wolfenstein 3D where it works right with the mouse. As soon as you move the joystick right, it starts to pop up the menu every a few seconds or so, like on its own, off and on. And I thought, is there a controller problem? So I swapped the compact flash card over to the 4000 with the TF4060 in it, and no issues at all. So I don't get it. I honestly don't know what's doing that. And it's just that one game. Everything checks out here though. The joystick ports work fine, mouse works fine, no issues at all. Right, that's gone through one time. It did take about 15 minutes, but that was pretty quick for 128 meg. So I'll switch that off. The 2000's on test over there, which is what you can hear. It's a wee bit loud perhaps. Let me just get the wrist strap on. So I found my other 68060 here. It's got an unusual part number on it. I'll stick the part number top left. It's a really oddball part number. I guess that came out of some telecoms equipment. Anyway, we'll take this off. It's just lukewarm. It's been on for about an hour and a half, 2 hours. So just very carefully use the PGA extractor here. If you've not got one of these, get one. There are a few people who've been selling these, I think, on Amiga. It's far better than just trying to lever it out with a screwdriver for sure. And if you just take your time and just go like, I don't know, quarter, half of a millimetre at a time on each side, eventually it'll come out without any damage. There we go. So let's carefully lift that out. Put that on top of the drive there. So the missing pin here is there. So I need to carefully align that missing corner pin. And squeeze it in. Right, let's get that in place. I'll test it at 50 to start with. And that booted okay at 50. Right, this set to 100 megahertz. Let's try it. And the same thing where we get that yellow screen there. It's curious, isn't it? Bit of hex in there playing on the demo. It runs incredibly well. This demo doesn't run that well though. It's like, I don't know whether it's glitched. Can you see, look, it's just hitting nothing. I don't know whether that's a glitch to do with the way it was ported. I don't know, maybe it was like that on the original. Because as this plays out here, I'll fast forward here a bit, you'll see he starts actually attacking the enemy properly when the enemy comes in. Yeah, you can see as the enemy comes in, he does actually attack it, you know, or defend himself. It's weird, that demo. Anyway, the game runs really, really well, as does Doom. You can like zoom around it. And I was thinking about a cooling solution for this, and honestly, I don't think we need one. I know we don't. It's not like I think we don't. This is just like lukewarm, and it's been on for like 2 hours or something. So the default 50 megahertz, you don't need a heatsink at all. And just making sure I've grounded myself here. Nothing needs heat sinking on this. It's incredible. Those are just lukewarm. So my intentions are using this amazing fan here that came with the TF536, which would be a bit hypocritical, wouldn't it? This is competing with the TF4060. I'm going to save this. At some point I'll try and get the TF4060, you know, the actual release version, PCB, and build one of those up, and we'll use that with that, I think. Yeah, a short intermission on the subject of Christmas. It's been a pretty tough year for me in many ways this year. It really has. YouTube revenue's just gone down the pan, like advertising. I may as well switch advertising off. I may do that because you just don't make any money on advertising. And if it wasn't for all the donations, cards, gifts, all the things that have helped me this year, the channel wouldn't have lasted this year. To all of the people in my Discord, all of my Patreons, every single one of you, all of the coffee donations and things like this. Novabug, you know, he didn't have to send me a card. He just did this. He was asking people, do they want a card? And I didn't mention anything because I didn't want the expense of him having to post me a card, to be honest. And he's done it. You know, he's got these himself. That's his logo from his second game, actually. And I bought that recently. It was only a few pounds. It's well worth getting if you've got a CPC. Thanks to Novabug for that. This one came from Rich Palmer. It'll be in a separate video with a gift that came with that. This came, you can see it's been opened, but it's on hiding, what's the word? It's on a hiding schedule at the moment. It's in here, so that my wife doesn't eat any more of them, because I want some of them, and she's had a couple already. Yeah, Tim Tams, all the way from Australia. Those came from Eric. massive thanks. And again, there'll be a video covering the thing he sent me with this. And this time last Christmas, he sent me something else as well, a small gift. That video's coming up soon as well. And you can see, these things mean a lot to me. I keep my cards, I've had the birthday cards every year. That's another one from Eric last year, with the other video. Oh, that's from Novabook. Hang on, there's one with a reindeer somewhere. I don't know where it's gone. It's in another pile, I think. But trust me, I keep all these things. They mean the world to me. So thanks very much for these ones this year, Novabook and Rich, and the stuff that came from Eric. Yeah, so I'm very grateful. I'm wishing you all a Merry Christmas. So filmed a lot later. I've been using the BFG for quite some time now. You saw me fit it actually when I did the RTG card that came from Barry, the P2++, because the TF4060 wouldn't coexist with it, and it was just because it's a proto, the TF4060. At some point I'll build a TF4060, a full one, or buy one, because I'm not sure you can build them yourself just now. We've got the full 060 in here, which was the one I bought myself, and I fitted it on the TF4060 Proto. So using the full 060 here, just thought I'd show you some of the games and demos that I've been running here that run on the, you know, full 060. Got a Quake on here. Let's see what that looks like on the BFG. And there are a few different versions of Quake. Anyway, this is the version I go with. It's used quite a big heat there, 255 meg again. Yeah, so not especially quick on its default configuration. And I suspect it's because of that heap size. We had exactly the same thing when I looked at the TF4060. That if you use, not really the TF4060, but actually when we looked at the Zorro 3 RAM card from Live 2, it's that slows it down. So if I come out of that, I've probably still got an icon set up here to run it with a 32 meg heap, if I can find it. Where is it? Somewhere in this folder. There it is, Quake 32 meg. So if we do that, it'll start with a 32 meg heap. I could go smaller, bigger, up to 128 meg, which means it'll fit into the local RAM. Look at that, that's much quicker. So this is what happens when you use the RAM on the BFG, rather than, you know, Zorro 3 RAM, or Zorro 2 RAM, or, you know, Ramsey RAM, if that's the thing, you know, the Sims. If you use the local 32-bit fast RAM, it rockets along, it really does. And this is not an optimised version of Quake for the Amiga. I think there's a later version of this particular one, but there's another build as well that runs even faster. So you can argue I'm running a slower, slightly out-of-date version of Quake here. But it runs really, really well. And this is one of the things with the BFG that stands out perhaps above some of the other cards. I'm not sure about the latest TF4060, but the RAM speed on it is one of the things that people have been raving about. Yeah, it's very quick. It's on par with, you know, how it played out on my Falcon when I ran my Falcon at 100 megahertz. Bear in mind, this is just running at 50 at the moment. So yeah, there's a lot of scope there to get even more performance if I increase to 75 or 100 megahertz. And this full R6 will do 100 megahertz. I know that because I tested briefly at the full 100 with the BFG, but because it's a jumper in order to switch the speed over, that's one thing I would say the TF4060 stands out above this, because you can do it software on the TF4060. What I don't want to do is hard code it, you know, with the jumpers to 100 megahertz and run it at 100 all the time. I don't want to do that. I know that as long as you've got proper cooling, chances are you'll never have an issue. But I think that would be foolish. 68060s are so blooming expensive. I really don't like the idea of it running 100 megahertz all the time, even if it is cooled. I'd prefer to be able to do what you can do on the 4060, which is to, you know, if I want to play this for an hour, boost it up to 100 megahertz, play it for an hour, reset the machine, and back to 50. That would be nice. But with the current build of the BFG, you can't do that because it's, you know, it's jumpers. Anyway, that runs exceptionally well at 50 megahertz. Yeah, and as you'd imagine, with an 060, you can obviously play your MP3s and things, even at 50 megahertz, without an issue. If I load that garbage. Perfect. There's a new version of Sysonfo in the works, I think. This is Stefan R, the amazing guy behind the A4091 remake. He's upgrading that, you know, updating it. But I added the boards in, you know, you can add, there's a file you can add in, I think it's in S, with the identification, you know, the manufacturer code and the, you know, the individual serial number, whatever it is. Yeah, so I added in the BFG, you can see at the bottom there, BFG9060 from Matsei. The thing above it is the 4091. We'll have a look at that from Stefan R. We'll have a look at that in an upcoming video. Liv 2's card. There's a reserved manufacturer thing, so I can't actually add an identification thing to say that that's the 256 meg Zorro 3 from Liv 2. And then, as you can see, there's the video where we added the BFG, the GBAP2 Plus. So we've got the RAM for it, and then the you know, the 64K of I/O. So those are the things in this 4000 at the moment. And you can of course play this game with the BFG, the latest version of Outrun. There'll be a link down below where you can download this. Yeah, BFG just flies on this game. Bear in mind, we're only got at 50 megahertz here. And of course, when you've got a fast CPU like this, you can emulate a lot better. So this is a Spectrum emulator. Bit slow. Ah, there we go. So cool. It looks like a real Spectrum, doesn't it? It's pretty good, that. A AGA Spectrum emulator. Yeah, and if I run a bus test fast here, that's really fast. Look at that, the speeds. If you remember when we looked at, say, the Zorro 3 RAM board from Liv 2, I was seeing like 9 or 11 or something there, so it's like this is exponentially faster when you've not got the bottleneck of the Zorro interface there. It's incredible how fast it is, and I might not have the switches set right there. But in any case, yeah, that's looks like it's rocketing along in the memory access. There'll be a link down below to Wrangler's video, because he did a much more in-depth video looking at the benchmarks. So do watch that video on Wrangler's channel if you want to know more about the actual performance metrics of this card. Right, so this demo is Rift. We've seen this before on the Atari Falcon. I quite like this demo. A lot of the TBL demos are really good. Music's a bit quiet there. Not sure how the music's done. It must be MHI, I think. Yeah, so yeah, things like this just run incredibly well. I mean, you can run this on an 030 pretty nicely, to be honest. But the BFG just annihilates it. It really does. The dogs. Yeah, so it's using an RTG mode at the moment, but that's one of the nice things when you get a fast CPU, you can do more with RTG. That's it, enter. Oh. So you can see it runs exceptionally well. I'm not very good at this. Oh, I just ran over someone. Oops. The police are after me now. Oh, police are really going for it. Oh, you can switch motion blur on. That's interesting. Obviously uses more CPU. There you go. You can see we've got the lighting effects and everything. Oh, I can rotate as you go forward. Oh, it's like that. I tell you what, it takes a bit of getting used to. I used to be a master at this game. I like playing it online as well, or with the modem. So yeah, it's really empowered my machine for some of these old DOS ports. Very cool. So thank you ever so much for everyone that contributed to that on my birthday. It really made my birthday special, and it's made last Christmas special because I just built it just before last Christmas, I think. And obviously, huge thanks to Matthias Heinrichs as well for creating this for the community, open sourcing it. You know, there'll be links down below to his GitLab page where you can get the Gerbers and the source code and everything. So it's just amazing. He's right up there with Stephen Leary in terms of, you know, just pushing this stuff out for all of the Amiga community, but, you know, ultimately open sourcing things as well. It's just brilliant, absolutely amazing work. If you did like the video, please give it a like or a share. If you'd like to support the channel, please see the Coffee and Patreon links down below. I'll catch you in the next video.